Consider the position function r of t equals 2ti plus t cubed j. Do the following sketches on the same plane. Sketch the curve given by r of t. Okay, I think we can do that. Okay, so how do we plot points here for r of t? This is a basic skill everybody should have. So make a little chart. What would be some good values to plot? Now, do we have to plot in a whole bunch of values and get the best looking curve in the world? What's the t value that you're analyzing here? 1. So just plot it near t equals 1, right? You'll want to plug in a couple other t values, but you don't need to go crazy. So definitely t equals 1. What would be another good value to plug in? 0, and then what else? 2. That might be enough. So I'm gonna do it this way. You could always eliminate the parameter to check your work. So if I plug in, say, 0, let's get all the x components for 0, 1, and 2, actually. So if you look at this guy, x of t is just 2t, right? So we're going to double it. Let's see. You double 0, you get 0. 2 and 4. Does everybody buy that? And then what do we get for all the y components? So y of t is equal to t cubed. So plug the t value into the cubing function. What do we get? I'll do the 0 for you. That was easy. 1 and then 8. Do you want to do a negative value just to be safe? Be safe. Do a negative value. I don't know what that means. So negative 2, and then what would be the y value? Negative 1 again. Okay. So, all right, maybe I should have got some graph paper here. You know what I'll do? I'm going to go grab some graph paper. If I can find it. I have a file for graph paper here somewhere. Give me a second. Here's funny graphs. You want to look at some funny graphs? Okay, here's a good one. Can you see that? It's the relationship status versus the probability of being right. As you go from single to dating to relationship to engaged, it just goes down. Okay. All right, that's not the one I wanted. Here we go, graph paper. All right, 0, 0, 2, 1, 4, 8. 1, 2, 3, 4. 1, 2, 3, 4, 5, 6, 7, 8. I do realize this is like watching paint dry when you watch me plot points. Negative 1, and then negative 2, negative 1. Something like that. So it's going to, I would argue this is just as easy as, graphing this thing is just as easy as eliminating the parameter, graphing it with what's given. It's going to be something like that. Now, you could also, and then I think it goes down after that. What could you also do? You could also graph it really quickly on your TI calculator, couldn't you? Parametric mode, right? Does everybody know about that? Okay. So that's part A. I imagine that didn't give you too much trouble, right? Then part B, it says sketch the acceleration vector at t equals 1. Make sure its initial point is at r of 1. That'll be a point on the curve given by t equals 1. So let's find, just so I can keep a lot of this stuff on the same screen. That is not what I meant to do. There we go. Let's move this stuff over here. Okay, and you guys tell me, how do I find the acceleration vector? So you got to find the velocity vector first, right? And that's r prime. So what's r prime? I'm going to do, just because we haven't used it yet today, I'm going to do component form. So what would r prime or v be? Same thing. 2, 3t squared. Okay. Okay, but we're in the plane, so we don't need to worry about the other component. And then a of t, would be 0, 6t, and then we want basically a of 1. It's telling us a of 1 would be what? 0, 6. Okay? So, I need to know, to plot this, I want to make sure its tail is at r of 1. Well, we know what r of 1 is. What's r of 1? 2, 1. And unfortunately, you see that I moved my graph. So, okay. That part of the video will be edited out. And you wonder why it takes me a long time to post these things, because stuff like that happens. Okay, so what's r of 1? It's this guy, right? So we're going to plot the tail of this guy at 2, 1 right here. Oh, okay. So we treat the point 2, 1 like the origin and plot the vector. Oh, okay. So 0, 6, I go left to right 0 and up 6. Does that make sense? All right. So I can do that. I'll do that vector in green. Up 6. I don't know. Is that 6 yet? 1, 2, 3, 4, 5, 6. There we go. So I should be at a height of 7. Okay. So there's my, I'll label it later because my labels might get in the way, but the label, the vector in green is my velocity vector. I'm sorry, yeah, of course, it's A, yeah. In the next part, sketch the vectors ATT at 1, right? And A sub n times n, the principal unit normal vector evaluated at 1. Make sure the initial points, the tails, are at r of 1. Okay? So, all right, so we've got to figure out how to find, well, t to start with, right? Wouldn't that be a good goal? Okay, so we know, what do we know about t? So this is for part C. What do we know about t of t? We'll worry about the 1 in a second. Okay, so it's r prime or v of t divided by its magnitude, right? And you can think of it as r prime divided by magnitude r prime either way. Okay, so we have v of t, right? We just need its magnitude. So what's the magnitude of v of t? So it's the square root of, let's see, 4 plus 9t squared to the 4th, yeah. 9t squared squared is what I meant to say. Whoops, let me get this right. Yeah, this guy squared. Let's just say it that way. 9t to the 4th plus 4. Would you buy that? Okay. And then that makes t of, okay, let's just do it all at once here. T of 1 equal to what? So what is this guy when you plug in 1? It's the vector. When you plug in 1, what is this guy? 2. Don't just answer. What is this guy when you plug in 1? 2, 3. Okay. And then what do you have in front? 1 over root 3. There you go. That's all I was after. Okay? Now, it's going to be easier to scalar multiply. So we get 2 over root 13, and then 3 over root 13. Okay. Now, what do we need to find now? And I think I'm only going to have time to do one of these, and we can get the other one just by looking at the picture, but we can also get it symbolically. I'll talk about that. I'll give it lip service, but I won't have time to do it. So we want this guy, don't we? Would you agree? Okay. And then I can multiply that times what I just found, and then I can draw that vector. Does that make sense? Okay, so how do we find a sub t? We have a nice formula for it. A sub t That's the tangential scalar component of acceleration, right? A dot t, right? A dot t. Okay, but it's all evaluated at 1, right? So can't we make our life easier by evaluating it at 1 first and then taking the dot product? Yeah. So, well, is that even necessary here? Well, yeah, no, we already did it, didn't we? So what is that going to turn out to be? That dot product is the dot product of 0, 6, and this guy, right? Would you buy that for $1? Okay. $2. All right, I'm getting rich tonight. Okay, so then okay, do the dot product. What's a sub t turn out to be? 18 over radical over radical? Over radical 13. Radical, that's a new word. I made that up. Yeah, sure, why not? Okay. Does everybody believe that? Yeah? Okay, so then let's find that vector. So a sub t times t evaluated at 1 is going to be 18 over root 13 times t of 1, right? Which is 2 over root. Oh, that's going to be nice. We got some cancellation there. Does everybody believe that? Okay, so now let's scalar multiply. What do we end up with? Is it 18? How about 36? So 36, so this is a vector we're finding, right? So 36 over just 13? And then what's 18 times 3? 54? 54 over 13? So get a decimal approximation accurate to 1 decimal place for me for both of these. So it'll be close to 3, but so just run through your calculator real quick for me. 2.8, yeah, that sounds about right. Then 4.1 or 4.2 approximately? Yeah, okay. So I'm going to graph this guy. Let me bring it back up to my picture here. Okay, now I'm going to again make the tail of this point in yellow here, which is 2, 1, R of 1, right? So that means I treat that point in yellow like the origin, and I go right 2 point up, it's getting late, 2.8 and up 4.2, okay? So if I do that, I'll do that in blue. So right 1, 2, almost 3. I'm not going to be able to tell the difference really on this. And then 4.2, 1, 2, 3, 4, which, just a hair over 4. And you can see, now this should look tangent to the curve, right? Because it's just a scalar multiple of the unit tangent vector. And that looks pretty good. Okay? Now, I'm going to cheat. It's not really cheating. It's being a little clever. So that's not t. It's a scalar multiple of t evaluated at 1, right? Now, yeah, it's going to take a longer explanation, actually, than I would like. I can estimate it visually. Now, if it were just n that you were graphing, you could flip the components around, and you know that n has to point in the direction that it's the curve is carved out kind of that way. So it's got to turn in that direction, which means n is going to point kind of in that direction that it's turning. So n would have to point this way. And you could figure out what it is if it were just n by flipping these guys and making the first coordinate negative. But because it's a sub n times n, there's a little more to it than that. But it's just a Pythagorean theorem that you could use to get it. But I could estimate it by going like this. I do know that it has to be perpendicular to the blue vector. And I do know that A evaluated at 1 is the sum of these two vectors, right? And if this is a right angle here, I'd have to stop it about right, well, probably a little bit before what I did, so that when you take a copy of this vector and put it on its tail on the tip of a sub tt, the triangle law would make it so that they add together. So I know that that vector in orange is close to being right, just visually. So just visually, this would be close. This vector in orange would be close to a sub n times n evaluated at 1. Now again, so I'm going to stop there because we're done in 10 minutes and we still haven't talked about the test yet. But I will point this out. It's not any tougher than what we just did. There's a couple different formulas you could use. You could use a dot n, or you could just take the square root of the magnitude of a squared minus a sub t squared. Either formula will work to get you a sub n, and then you could multiply that times using that trick to find your n vector. You could just multiply it times that vector. So your n vector, you would flip these two guys and put the negative in the first component, and there's your n, right? So that's the trick I was talking about, but it's just a little bit more work to find n.